Kia ora everyone, today I'm going to show you how to solve 3x3 simultaneous equations using the substitution method. Now, 3 variables and 3 equations makes a plane, and these usually meet at one point, which you can see in the diagram. So we're trying to find the values for x, y and z. We use the substitution method when one of the equations can be rewritten to be x equals, y equals, or z equals, and then we take that and substitute it into the other 2 equations. This forms 2 equations that we can solve like we have previously. Now, it's really important that you carefully label your equations and write down what you're doing so that you can keep track, and it's easier when we come to marking. So this example comes from the Walker book on page 13. We've got 3 equations, and I notice that I can take equation 1 and I can rearrange it to be x equals. So I'm going to do that by adding 2y to both sides and adding 3z to both sides. So that gives me negative x equals 5 plus 2y plus 3z. I want my x to be positive, so I'm just going to flip all the signs. So x equals negative 5 minus 2y minus 3z. And this is still equation 1. So what I'm going to do is I'm going to substitute equation 1 into equation 2. So equation 2 up here, 3x plus y minus 3z equals 4. So we will copy that down. So 3x plus y minus 3z equals 4. And instead of the x, I'm chucking in the value negative 5 minus 2y minus 3z. So 3 lots of negative 5 minus 2y minus 3z plus y minus 3z equals 4. I'm going to expand out the brackets by multiplying, which gives me negative 15 minus 6y minus 9z, and then plus y minus 3z equals 4. Now when I simplify this, so I simplify my y's, so negative 6y plus y gives me negative 5y. My z's, negative 9z minus 3z gives me negative 12z. And then I'm going to take the negative 15, I'm going to add it to both sides. So that is 9 plus 15, which is 19. And this becomes equation 5. Sorry, it's equation 4, my bad. Now I'm going to follow the same steps. I'm going to substitute equation 1 into equation 3. And equation 3 is negative 3x plus 4y plus 7z, which equals negative 7. So that is negative 3 lots of negative 5 minus 2y minus 3z. Oh, sorry, I'm looking at the wrong equation. Yep, no, that's right. Plus 4y plus 7z, which equals negative 7. So now I expand out the brackets, so I get 15 plus 6y plus 9z plus 4y plus 7z equals negative 7. And now I can simplify it again. So I'm going to look at my y's. So I have 6y plus 4y, which is 10y. I'm going to look at my z's. 9z plus 7z is 16z. And I'm going to subtract 15 from both sides. So negative 7 minus 15 is negative 22, and this is now equation 5. So let's look at equation 4 and 5. So I've got 5y minus 12y equals 19 for 4, and 10y plus 16z equals negative 22. I notice that if I multiply equation 4 by 2, then I will have 10y in both of them. So I'll be able to add them together to eliminate the variable y. So I'm going to take equation 4 and I'm going to multiply it by 2. So I get negative 10y minus 24z equals 38. And I've got equation 5, which I'll just write down below. So 10y plus 16z equals negative 22. So I'm going to add these together. So negative 10y plus 10y, they cancel out. 24z, negative 24 plus 16 gives me negative 8z, and 38 minus 22 gives me 16. I'm going to divide both sides by negative 8, so z equals negative 2. So this here is my first solution. So I've found z. The next step is I want to find another variable. So if I take z equals negative 2, if I substitute it into one of my variables, I'll be able to solve that. So I'm going to substitute z equals negative 2, and I'm just going to put that into equation 4. So negative 5y minus 12 lots of negative 2 equals 19. So therefore negative 5y equals negative 5, and y equals 1. So this becomes my second solution. So now I can substitute z equals negative 2 and y equals 1 into equation 1, which is the one that was x equals. So x equals negative 5 minus 2 lots of 1 minus 3 lots of negative 2. Therefore x equals negative 1, which is my third solution. So what I've found is that the point of intersection for these planes is negative 1, 1, negative 2, or this could be written as x equals negative 1, y equals 1, and z equals negative 2. So that's one way to solve this. I have indicated that we have a tool that we can use in assessments. So once you have found your 3 equations, you can substitute them straight into this tool. Now it's really important that it's written in the form of x and then y and then z equals the number for the tool to work. So if we have a look at the tool, it's here, and you can see that there are these boxes where we can enter in the numbers. So for the first one, we've got negative 1, negative 2, negative 3, and then 5. So in here, we have negative 1. In here, the y value was negative 2. So we change this to negative. The z value was -3, so we change this to a negative, and in here we put 3, and the z value was 5. So we can type the 5 in there. Oh. Sorry, skipping back and forth means that it's creating problems. So for the next one, our coefficients are 3, 1, -3, and 4. So 3, 1, -3, and 4. 3, 1, -3. So 3, 1, -3, and 4. And our third equation was -3, 4, 7, -7. -3, +4, 7, and then -7. Okay, and we want to show the solution without the steps. The way that they solve these, they use different methods, so looking at the workings is not going to help. But what we can see is that the solution agrees with what we came up. So x equals -1, y equals 1, and z equals -2. I will make this copy of notes available on Classroom for you to look at as well. And if you do have any questions, please let me know. I'm happy to create another video with another example if that's what you need. There's plenty of work online on Google Classroom for you to go through. And if there's any questions, just get hold of me. Thank you.